Hit the record. We did 2 sections over unit analysis, 2A and 2B. Did anybody have any questions, lingering questions over those sections, I guess? For that, we had a test. So we did 2 sections on unit analysis. And this section, one of the things, if you know this first concept, absolute change versus sort of like this relative change. Absolute change is just like what you think it is. It's straightforward. How do I talk about the difference from this number to this number? So the first thing that they're going to ask is to find absolute change. And then the next question we're going to answer is to find the relative change. And so this section we introduced absolute change, which means absolutely how much does this go up? And then relative change is where you find the change relative to the amount that you start with. Okay, so I know you're going to get a number from subtracting those two things. The other thing is that we are in the units of millions. So don't forget like that thing too. Million. So this is a one step. It should take you like 10 seconds if you watch this lecture video to know what to do here. Absolute change from one number into another. We're going from 8.7 million to 16.1 million. All right, I should not be taking that long. Where we go. So 16.1 minus the 8.7 should give you 7.4. And what'd y'all say? Not say the millions or something? It should be 7.4. Should be positive 7.4. If you told me, yeah, if you told me 7,400,000, that's also correct. That's the same number. You got to count for the millions one way or another, either by saying the word million or expanding it out, right? That's it. We take the two numbers, we subtract them. That's the absolute change. So this is the absolute change, and the relative change is we compare it to the number that we started with. So now we're comparing this 7.4 million. What would that be relative to starting out at 8.7? And so relative change should be a percentage, and it should be a percentage to 2 decimal places. And so they did this thing with absolute change and relative change. Well, I'll wait till we answer this. It's on the next slide. All right, so after you find absolute change, finding relative change, it really should be 10 seconds. Like if you're not getting this in 10 seconds, I would put my money on you probably didn't watch the video.
So we go to the most we goes 2 decimal places, correct?
Yeah, so you want to go to 2 decimal places, but you want it as a percentage. So if you're going to convert a decimal to a percent, I think you're gonna have to go like 4 decimal places and do the conversion, right? If that makes sense.
Yeah.
Yeah. And so you should be taking that 7.4, and to find what it is relative to the 8.7, you divide it, right? You let like 8.7 be your base. And so I know I talked about this in the notes, but like one of the things about like percentages is that they're really deceptive, right? If I talk about 3% of this class population, I may not even be talking about a person, right? There might be one person in that if I talk about 3%. What are y'all saying? 85? Did you not put percentage signs? What are you doing? 8505, 8506. I think it should get rounded up. Okay, I just like some rounding issues. I don't know where 1.1 or 45 is coming from, but it should be 85. So the 85s look like they're getting it. But where is this coming from? We're doing new minus old over old. And this is the relative change. There's also relative difference. But like it's the same formula as this, right? It's new minus old over old. They change the words around. Instead of having like a time sort of thing where we're going from 2005 to 2015, we might just be comparing two objects, right? And so then there's like, what do they say? Compared minus reference over reference, but it's the same basic formula. If you know new minus old over old, that will probably get you there, right? Okay, so this is the difference. If we look at the top, that's our absolute change. So if you find your absolute change, you can use that sort of information to find your relative change, maybe a little bit quicker. But this is 85, and if we round it out to 0.06%. Questions about this? Find the absolute change and relative change in the following cases. All right, new numbers. I don't think I was as picky here with the units. So I think the units on here should be what? Pounds for the absolute change? All right, so this should take like 10 seconds. Oh, shoot. Wait. Got to be careful on this one. Forgot about that. I messed up. It's decreasing from this to this. So make sure you put those in the right order. That is important. I messed up. It's going to give me a womp womp sound. I realized it after I hit the button. I'm waking up still. Let me go drink some coffee. All right, so what it should be, if you got 12.4, you did what I did, and it's not going to count it correct. It should be a negative 12.4. The new one is the 55.4. We're going to subtract 55.4 minus 67.8. Oh, come on. It looks like y'all were more awake than I was on that one, Baron. What'd y'all do? You did the same thing as me. Okay. Yeah, so you got to pay attention to which one is your new, which one's your old, which one is your compared, or which one's your reference, right? They will usually try to set up the problem so that it's obvious. I will try to do it so it's more obvious. So now we want to do relative. So we know it's a minus 12.4, but which one is the one that we're starting with? Which one is our relative amount that we want? So which one of these should we divide by? I think is the question. And remember, these are in percents. All right, so this should be one operation. You should divide by one of these numbers and convert to percentage. Oh, I got to exit out of the full screen. That's right. Minus 18.29. So we have to be careful which one we're dividing by. So we want to divide by the old or the original price, which is the 67.8. So new minus old over old. So 55.4 minus 67.8, and then we divide everything by the 67.8. What do y'all say? Minus 18.3, so just rounding, that's good. You're still getting it. Yeah, it should have a percent sign on there. I think you just got your decimal place there, hopefully. Okay. The life expectancy at birth of American women is 81.2 years. This is blank percent greater than the life expectancy of men, which is 76.4. Okay. So this is kind of hinting at which way you should subtract them, I think, right? If this one is blank percent greater, do we want it to be positive or negative? I think that kind of hints at which direction you want to subtract it. So you want to subtract them and then you want to divide them, right? And so you subtract them, you get 4.8. Now we got to ask ourselves, which one are we dividing by? Did I do that right? Oh, I didn't do that right. Oh, talking was not paying attention. Okay. So here, and it was not obvious, but they're asking for the relative change, right? The absolute change would be like 4.8 when we subtract these two. So if we do a relative change, that will tell us. So the thing you should start with is that 76.4 should be your reference, right? Or your old. Should be 6.28%. Did I not put percent on here? 6.3%, good enough. Should be positive 6.3. Yeah, about 6.3. It should be the 76. I think the other ones are dividing by the other one, right? Is probably what you did. They say it is this percent greater, so we want a positive number. If this one is greater than this one, we want the positive direction. So that would be the 81.2 minus the 76.4. If this is the new minus old, this would be the old. right? The direction that I subtract them in determines which one I divide by. It's always the second one, the old one. I guess reference in this case, right? We don't really have that time sort of thing happening here. In 2015, the median age of the first marriage of U.S. women, excuse me, was 27.1, was blank percent less than the median age at first marriage of the U.S. men, which was 29.2. So this one, they want the percent that it is less. So they're giving you kind of a hint, but you should be getting a negative number, but like kind of tossing out the negative, right? This thing saying less than is telling us it's going down. So we don't need the negative in there. Does that make sense? So you should be getting a negative number, but then they're accounting for it with their words. So we really don't need it, I think. I don't think I put it. I hope not. I said I didn't. That's right. If I'm being honest, I feel like this is probably like maybe one of the more like confusing word problems. It's just like it's not super obvious which one should be your reference and which one should be your compared. I think it's the book. I think those are the words the book uses, right? Compared and reference, something like that. So hope you're doing what? 27.1 minus the 29.2. And if we subtract this one, if we do this one minus this one, we have to divide by this one, I believe, right? Okay. So it should be what? 7.19, I think. If you got 7.75 or something like that, I think you divided by the wrong number, maybe. Wrong reference. What are we doing? Dividing by 7.1. All right, so 7.1 is close. 7.2 is close. Yeah. Didn't convert. You got to convert that to a percentage. It's getting warm in here. The population of Michigan is 63% greater than the population of Missouri. So the Michigan's population is blank percent of Missouri's population. So this is a sort of vocabulary sort of thing that we talked about in the notes. But this is the comparison of percent greater than versus percent of. So how do those things relate? So how would you get to Michigan's population from Missouri? You're going to take Missouri's population, you're going to increase it by 63%. So if we take one of their population, what percentage of the population is that? And then we're going to add 63%. What percentage are we going to get?
Could you explain that again?
Do what now?
Could you explain that? Can you explain it again?
Okay, so in order to get to Michigan's population, which is 63% greater than, you would take 1 of Missouri's population and you would add 63% of Missouri's population to it. So how much is 1 of the population in percentage? We're talking about the whole thing, and then we're going to add 63 more to it. So how do we say the whole thing in percentage wise? And then you add 63 to it. Oh man. What do you get if you answer every question right on a test? How do we say the whole thing in percentage? Man, this should be like a quick as one sort of like vocabulary. I'm not trying to spend like more than a minute on this question. It really should be like really quick. Tell me. It is 100% of the population, and then we're going to add 63 to it. It should be, yeah, 163. That's it. You would want to do maybe like 1.63 would be the decimal version, but I'm not sure. Let's see where 16.3 is coming from. Okay, so the population of Hawaii is 52% less than the population of Arkansas. So the population of Hawaii is blank percent of the population of Arkansas. So this was the, if it's going up, we have 100 plus P. Now this is going down. How does that relate? So if you're decreasing a population by 52%, how much of that population are you going to have left? I laugh because I said Arkansas. Whenever I like learn states and stuff, like I used to say Arkansas for the longest time. And I still stand by it. They should spell it differently if they want me to pronounce it differently. All right, so this is a one-stop sort of thing. If we start out with 100 and we take away 52, we should be left with 48%. Yay. The wholesale price of a toaster is 30% less than the retail price. Therefore, the wholesale price is blank times the retail price. So we just did this. If we wanted to do this with a percentage, we would take 100%. We would minus what, 30 to get to 70%. So the price would be 70% of the retail price. But what would that be times? What is the number that you would multiply by? Oh shoot, typing into the wrong device. And so they're kind of asking the same question, but they want it in a slightly different format, if that makes sense. Instead of us as a percentage, we want it as the number, as the decimal, right? What is the number you're actually going to multiply when you put it into a problem? And so it should be 70%. And so it should be 0.70 or 0.7, something there, right? Yeah. What are y'all telling me? 70%? Yeah, not the percentage. They want the decimal. 0.7. It should have counted all those correct. I don't know why it's not counting 0.7 right. Or maybe 0.70. I don't know. Maybe I didn't put that in there. 0.70 is the same thing. The original price of a TV is 20% more than its on sale price. Therefore, the retail price is blank times the on sale price. So now this is very similar to the sort of previous things. So if we do go down, we do 100 minus the P. If we go up, we do the 100 plus the P. And then convert that to a decimal. So 100 plus this, convert to decimal. All right, so we're doing 120%. We convert it to a decimal. It should be 1.2. If you said 1.20, that's good. Okay, what are we saying? 1.2.8. Oh no, we gotta go up, not down. We're going up this time. What is this? Is just messed up. Come on, load up. Describe each of the following something changes as an absolute change in terms of percentage points and as a relative change in terms of a percentage. So in case things weren't confusing enough, now we're doing percents of percents. Woo. So the percentage of Republicans in the House of Representatives increased from 40.9 to 55.3. So if we want to talk about things in terms of percentage points, this is the absolute change between these things. And so this is really getting at some vocabulary sort of things. So if we want to talk about the absolute change between these things, I already kind of told you how to find absolute change. It's straightforward. You get a number. But this, I'm going to be a little bit particular with units. You should say the word percentage points when you answer this. So if I'm talking about the absolute difference of two percentages, I should say something about them being percentage points. And percentage points, just to make things thoroughly confusing, percentage points are different from percentages just by themselves, right? If I say that word by themselves. Like, absolute change is percentage points and relative change is the percentage. And I think they even talk about it like this thing is interchangeable with the percent sign, right? This one is not. It is different. We're talking about the raw number of points that it goes up or down. All right, so this should be one operation to find the absolute change between this number and this number. There's one operation you got to find. You got to find your number and then you got to put the word percentage points on there. I'll give you all like 10, 15 seconds. Okay. So we're at 14.4 is what the difference is between the two things if we subtract them. And you should say something about them being percentage points. It should go up. It should be positive. I think someone's already answering the next one, maybe. Now we want to know what the relative change of these things is. So what is the relative change of from this number to this number? And this one is a percent. You can either say the word percent or you can give me a percent sign, but there should be a percent in there somewhere. So we know the previous one was what, 14.4? The absolute difference is 14.4. So we're taking this. And you basically got a 50-50 shot at getting it if you know what you're doing, right? But this one has a new minus old. I don't think it's too hard to find the old one on this one. Hopefully. Whew. Okay. Okay, so you should take that 14.4 and you're dividing it by the old one, which is what, the 40.9? Same thing here. We still have percentages. This is another percentages of percentages. Alcohol use by high school seniors. Alcohol use by high school seniors decreased from 50% in 2000 to 35.3 in 2015. So now we want the absolute change in percentage points. All right, so where are we at? Absolute change. This should like not take that long, right? It should be like 10 seconds. You're subtracting one number from the other. Yeah. So I believe it's going down 14.7. So you got to tell me negative 14.7. What do y'all do? Did you do positive? $14.7. It should be negative. Yes, I think the ones that are getting it wrong, most of them look like they got positive ones. And now we want the relative. So you already have your absolute new minus old. This should be one extra step. So this should take you like 10 seconds extra to find this. You already have your other information. You just need to know there's one step. You got to know which one to divide by, right? Oh, shoot. There we go. Maybe you got to convert a decimal to a percentage. Maybe it's a two-step if you count that. But there's one operation, right? And if you have your absolute set up and you know the formula, you know which one you have to divide by. So if I do new minus old and I'm doing 35.3 minus 50, I know I have to divide by that second number I just said. I have to divide by 50, right? Yeah, and you should say percent or put a percent sign on there. What are y'all saying? Ooh. Yeah, so probably divide by the other one. Should divide by that 50. So you got to figure out the right reference value. The total after-tax cost of a laptop computer is $1,278.24. The local sales tax rate is 7.6%. What is the retail, the pre-tax price? This one is a little tricky. This one requires a little bit of back solving. Okay, so if we wanted to figure out something from a pre-tax price and it goes up 7.6%, that's going to be what? 107.6% of the pre-tax price is this thing, is your after-tax. So 107.6% of this thing would mean that we're multiplying. So if we're multiplying this by our pre-tax price, or 107.6 by our pre-tax price, to get to here, how do we work backwards? So if we're multiplying this way, how do we work backwards to figure out that direction? And so this is one of those ones, I will go over it more after you give it an attempt, but I want you to try something. Round it to the nearest cent. What is the retail pre-tax price? What is the tax? It's 8.25, ain't it? Is that what it is? Federal tax. I know how to do it one time. You have to do it in those maybe they're not so rare anymore. Those rare instances that the power goes out and you can't use your cash register. Curious. I'm curious. Because this is a hard one. This is like one that people like. It is one of those ones that throws people for a loop for sure. Oh, that's not bad. What are we getting? 1187. Oh yeah, I forgot my comma in there. Shoot. So you probably got it. Man, y'all all got it, but I didn't put my comma in there, so yeah, computer's gonna be picky. I'm not gonna be that picky. But this is hopefully what y'all are doing. The people that got it, the people that don't. This is what's happening. We have one of these things. We have one of our retail price. So we start out, and this is kind of like what I was saying. You have to kind of do some back solving, right? You start out with 100% is what this is saying. I start out with one of my retail prices. I'm going to add my tax here. This is the 7.6% of my retail price. So we start out not knowing our retail price, which is why we had to do a little bit of back solving. But if I were to do this, right, if I were to start out doing it kind of the forwards direction, I would take 107.6%, right? And I'd multiply it by this number to get to this number. So now when we go backwards, what we have to do is we have to divide by the 107.6. So first you have to consider if the price is going up or down. You have to do it 100 plus it if it's going up, right? Or you may, if it's going the other direction, you might have to do 100 minus the number. But you also have to figure out, are you working with your reference price, right? Which is the pre-tax, or are you working with the post-tax price, right? Those things are found a little bit differently because we don't take the percent on the after-tax price, right? We're taking this percentage on our pre-tax price. This is our reference. So what a lot of people try to do is they'll try to take a 7.6% of this number for some reason, because it kind of, I guess it kind of looks like you should maybe, but no, that's not it. The pre-tax price is your reference. You don't know your post-tax price until after you find your pre-tax stuff out, right? Shifting reference value. Okay, so now we went through a few uses of percentages. Now we're getting into the abuses part, I think, is what's happening. If the national unemployment rate decreased at an annual rate of 2% per year for 3 consecutive years, is it true that you increased by a total of 6% over the 3-year period? So if I go down 2% each year, is it true that I went down a total of 6% over the 3 years? And this is, I was giving maybe a little bit of a hint, but this was the shifting reference value problems that we were talking about in the abuses of percentages. So state whether they're true or not, explain why a little bit. So would you say this is true? Is it going to go down false? Huh. Why is that? Is there some way we could prove it? Is there an easy way to prove it? Ooh. Yes, if we add all 3 years together, it equals 6. That's what some people might think. False. Each year, the inner rate is decreased by 2. Each year's reference value will be different. Huh. Because the rate is supposed to decrease to 5.9. I'm not sure why you're saying 5.9. I don't know where that number is exactly coming from. They might be right. I don't know. Okay, so like what's a good way? Like if I want to test it, right? If I want to test this thing and know whether it's true, it should be true of any rate that I pick for my unemployment rate, right? If I'm saying this overall, it should be true for any number I pick for my unemployment rate. So my first thing is pick a number, any number. Hey, guess what number I'm going to pick? Probably 100. So let's start out with 100. 100 is my unemployment rate. I don't know units. Maybe it's 100 people per 1,000 or something. I don't know. But 100's a good number to work with. It should work with any number. If it doesn't work with any and every number, it's not a true statement in math, right? So let's make sure it works with 100. So this is I can't even think now. Inductive logic, that's what I'm trying to think about, right? We're doing those sort of inductive proofs. It doesn't really prove it per se, but we get a pretty good idea of what's going on. So the first year, we're doing 100. 100 is the value that we're starting out with. If we want to go down by 2%, 2% of 100 is 2. So we take it down 2. We do 100 minus 2 is going to give me 98. My second year. Now this is what I think Richard was talking about. The reference value, right? Now we are not talking about 100 anymore. I am talking about this number I left off with, which is 98. So now I am changing my base or my reference value. So now I'm taking 2%, not of 100, but of the 98. So now I'm only taking away 1.96. And if you notice, we're not going down by 2. We're going down by a little bit smaller than 2, right? Sorry for that sound. Probably got your dogs barking there, but there we go. Third year, we reduced 96.04 is where we left off. And we reduce it by 2% of the 96.04, we get to something like this. And you might say, well, 94.1192, that's almost 6. It is almost 6%. But guess what? It's not exactly 6%, right? And so it is not exact. And 0.1192 is not a whole lot, right? But and I kind of thought about this, right? If you want to like really mess with someone, you can really mess with someone this way. Because what we're actually doing is we're doing 0.98 to the power. So if we want the first year, 0.98 to the first power is going to give me 0.98 or 98%. If I do 0.98 times 0.98, I'm going to get 96.04. You can really mess with someone and say, hey, let's reduce by 2% each year for 50 years, right? You should be down to 0% by then, sir. If you do that, you're actually at 36.4%, right? And so you could really like sort of manipulate people with this sort of thing, this sort of thinking, right? You're like, oh, I'm just going to keep reducing your bill by 2% each year for 50 years. They're still going to be paying like almost 40% of their bill, right? So this goes back, I think knowledge is a double-edged sword, right? You can use it to help people or you can use it to harm people sometimes. You can use it to prevent people from being exploited as much as you can use it to exploit people sometimes, right? But there we go. Is it possible to determine whether the following claims could be true? Explain your answer. Anna bought a surfboard online. She saved $125. Sorry, 125%. That is not saying the same thing I just said. Anna bought a surfboard online and saved 125%. Is that happening? I don't want to spend all day on this problem. Is it happening? Not possible. They would be giving her money. Exactly. They're giving away money. You can only get 100% off as $0. Yes. If they're giving you 100% off at $0, they give you anything over 100 on a sale, they're giving you money back. That's not, yeah. 100% off would be free. Anything over 100%, they're giving you money back, and that's not the way that works. So this is basically, you can't have a sale that's over 100%. That was one of the things they try to bring on home. Bring it home. Okay. Average hotel rooms have increased 100% in the last 20 years. Is that possible? Can you think of a number that might you could throw in there? Would it work? So if they're $50 20 years ago, and we increase it by 100%, is that possible? Yeah, it's possible. So if they were 50, well, I don't know. What do you say? $100 20 years ago? Let's say they're 50. They're $50 100 years ago. If we go up 100%, we're doing 50 plus 50. We're going up to $100. Yeah, it's possible. I've been following them stocks. Your stocks can increase by over 100%. It just means it's doubling, basically, right? If you increase by 100%, 100 plus 100 is 200. You are doubling it. Yeah. Okay. Suppose you have an 80% average in a class going into the final exam. You receive a 90% grade on the final exam. In general, does that follow that your average for the entire course is 85%? Oh man, I don't remember how I did this slide. I remember I put another slide after this one, but I don't remember what I put on it, if I'm being honest. I may not have finished it. Is what I'm kind of worrying about. But if I didn't finish it, I can talk about it. You have 80% average in a class going into the final exam. You receive that. Does it follow? Can't average out an average. Yeah. It's like in this class, I'm not really sure what they're asking in this one. Yeah, I don't think I filled out that next slide now that I think about it. I'll talk about it. In this class, things are worth different points, right? So in this class, it's definitely not true because not everything is equally weighted. So if I take 80% of 120 points and 90% of 10 points, that's not going to give me 85%, right? If everything is equally weighted, there's more questions going into the final than on the final. So the only way that this is true, there is a special, really special case in which this will be true. And it's true only if the number here is the same as the number here, right? If you have the same number of problems, then this is coincidentally true, it turns out. But like most of the time, it is not true. And you should not average averages. And this goes at, like, this is talking about 80%. Let's say there's 100 problems on all your assignments leading up to the final exam, and there's 10 problems on your final exam. You're doing 80%. Let me do my annotations. So what will we be doing then? We'll be doing 80% of the 100 problems leading up to the final exam. Then we'd be doing what? 90% of the problems on the exam. Is that giving me 85%? I don't think it is, because I think this is giving me what? 80 plus 9? It's giving me 89, right? That is not the same thing. Did I do that right? I think I did that right. So you would be getting 89% of your problems correct. This is assuming all the problems are equally weighted, which they're not in this class. So I'm assuming the book means like everything is equally weighted and it's not a weighted class like ours is. Because in ours is definitely not. You're taking different percentages of different points. And the final is typically worth more. I guess we don't have a final in this class per se. No, I didn't. Okay. I forgot to put my notes on that one. Sorry. 40% of the students at an orientation are women, and 20% of the women are engineering students. Therefore, 40% times 20% is 8% of the students at the orientation are female engineering students. This one, I feel like is a hair trickier. Is this true? Would 8% of the people in the orientation? So try it. Try a number. Try it out. Does it work out? Can you prove it? Like that would be inductively, right? Can I get a sort of like inductive proof of an example? Does it work for one example? And then if it does work for one example, true for one example, or did you find it true for everything? Because there's two different ways to sort of look at it, is what I was trying to get at. Yeah. It's a little bit harder to prove this one because like with the things that are false, right? When you make a false universal claim, like everything behaves this way. All I have to do is find that like one counterexample, right? 40% and 20%. So it might be worthwhile, like maybe thinking about these as decimals. If I do 0.4 and I multiply that by 0.2, am I getting 0.8? Ooh, I should really put some decimal places up in there. Oh man, whew. Yeah, I missed a decimal place. Sorry. I just realized that. This should say not 0.8, 0.08. Sorry. Definitely count your decimal places. That way you don't do something like that. Because this is 40%, this is 20%, this is 8%. All examples? You did infinitely many? That would be all examples, right? So you probably picked a few examples, right? That really gets at like, and I'm sorry if that sounded rude or anything. I wasn't trying to be. But those examples, they prove the examples that you use, right? We have to do a little bit more if we want to prove it for like every single number. And so as I was trying to do with this, if it brings up the next bullet, come on. There we go. Pick a number. I started with like 200 students. And so this is probably what y'all did. You said, well, 40% of 200 is 80. And if I do what, 20% of 80 is going to give me 16. And I go 16 out of 200 is the 8%. Well, that's correct for the 8%. So what did we do? So how did you get from 200 to 16? You multiplied by 0.4 and you multiplied by 0.2. And so this was the sort of process that we did. We start off with any number. We multiply it by 40% and then we multiply it by 20. So we start off with a number. And if we do that, this has to do with multiplication. You're multiplying one number by two numbers. It doesn't matter what sort of order we multiply things in, right? That would be associativity. All right, wait, no. It doesn't matter, yeah, whether we multiply these two first or whether we multiply these two first. How we group things when we multiply them doesn't matter as long as they're all being multiplied. And this is where we can see like the 0.4 and the 0.2 is going to give us the 0.08. And so something like this would be a little more formal with proving it for like everything, right? But I'm hoping this is the thing that's going on in your brain. It's like, well, we do these two things, we combine them, it's the same thing as doing 8%. 40% of 20. But as a general, try to stay away from doing percentages of percentages. Oh, come on. I ain't got time for your lost connection quizzes. All right, so where are we at? 50% of the cars in the real have Bluetooth capability, and 20% of the cars have GPS. Therefore, 50 and 20 equals, ooh, I like this one. 70% of the cars have Bluetooth or GPS. Is this true? And this one is a little tricky. This is a concept I feel like they throw out at you now, and it's a little tricky, but we go into it more later. So that's why it gets me excited, because we start talking about something here that we're going to talk about more later when we get to like statistics, probability. Actually, that's the probability one. Why is it false? What makes this false? Why can't we just add those two? And there's really like, there's a very specific region I'm thinking about. When we talked about or, I know y'all wanted to stay away from that logic after we got that first chapter, but I don't know what to tell you. Logic comes up in life. I try to tell y'all that. There's that either or. We want to talk about Bluetooth. We want to talk about GPS. Exactly. That's what I was trying to get at. There's that middle section. There's the Bluetooth and the GPS. And you're doing something really weird if you do this. You're missing an overlap. And so I think maybe if I just go look at my next picture, it might like help paint this maybe a little better than just saying some words out loud. So I think like let's look at this next picture, because I came up with a picture that fits exactly what they're talking about, and it doesn't work for what it says, right? So if we look at Bluetooth, well, let's look at the total number is what? If we add everything together, I believe I have 100 people here. We got 100 cars here. Now, if I look at my Bluetooth, that's the 40 and the 10. That is 50 out of 100 or 50%. My GPS is 10 plus 10, or 20 out of 100 is 20%. But if I want to add Bluetooth or GPS is what this should say. Wow, I used the wrong word there. I should say or. Definitely the wrong word there. Is 40 plus 10 plus 10, right? If we want everything that either has Bluetooth or GPS or both of them, I'm only getting to 60. Why is this equaling 70, but in reality, it's only 60? Where's that extra 10 coming from? Do y'all see it? And it's coming from the fact that you counted this twice. Because when we counted Bluetooth to get to 50, we counted this. When we counted GPS to get to 20, we counted this. When we added them together, we counted them twice, and we just added this thing together twice. So we just got an extra 10 in there from the overlap, basically. Is that making sense? I could separate these circles, right? Bluetooth could have its own circle if I really wanted to draw them separate. And this could say 50, I guess. I don't know if that helps or not. Trying to think of like better way to visualize this. But what I didn't account for was that area in the middle. I want to add those things together. I'm adding that area twice. Questions about this? Yeah, so when you do sets, right, and sets of things, you do have to think about their overlap when you start adding them and adding their probabilities. That will come up when we get back to probabilities. If we're talking about sets that have overlaps, we have to account for those sorts of things. That's like chapter 5, 7 towards the end there, I think. 4,550 men in the arena. Excuse me, compromise 85% of the people in the arena. How many people were in the arena? You should round this to the nearest whole person. We're not trying to quarter people here. So this is the one. We want 85% of the people in the arena. Do we know how many people are in the arena? That's the thing we want to know. So 85% multiplied by the people in the arena should get you to here. So this is one of those ones. You might have to do a little bit of back solving. Is that making sense or no? If I want to do 85% of the people in the arena, what does that look like? 85% of what? So what could I use to represent the people in the arena if I don't know it?
X.
Yeah. And now this is equal to what? 4550? Does that help out a little bit? This is that one you have to do some back solving. So if we're going one way, what's the operation? If we want to go backwards, what's my operation? Oh, come on, we're almost done. And then we have the weekend. Is
you
this-
gonna decide?
Are y'all answering this? Is it just lagging? Should be one step. Come on. Phew.
I'm kind of confused because I didn't get exactly a whole number. I got like point something, so I'm trying to.
It should round up, I think, right?
Okay.
Yeah, it's not going to be an exact number. That's right. Oh man, come on. I don't want to spend forever on this problem. Doing 85% of a number is going to get us to this. So if we're multiplying one direction, we got to divide to get to the other direction. So you should be dividing what, 4550 by 0.85, I believe, is what you should have done. 53, is that what we're getting? Oh, so that wasn't me who didn't answer, was it? Probably was. 53, it should be, yeah, I want to do the nearest whole person. I'm not trying to quarter people here. 53 men. Oh, here it is. Apparently I wrote it down. Yeah, so that's it. We're doing 85% of the amount of people there are going to be the amount of men. Ow. And so X, if we want to solve for X, we got to work this backwards. We got to divide by the 0.85. We're going to get that fractional amount. But we're not trying to quarter people, so round it to the nearest whole person. Okay. Oh, come on. In 2016, 84% of households with television subscribed to cable, an increase of 7.8% over 2000. What percentage of households with television subscribed to cable in 2000? What? That doesn't seem right. People aren't going to cable. People are cutting their cable. Like, it's maybe 2016 was like the last year it went up or something, man, because it has been going down. People are not going to cable. They are definitely heading away from cable. This is a little bit tricky because they're doing percentages of percentages. So again, if I want to do this, if it is an increase of 7.8%, what is the number that I'm going to multiply by? If I increase something by 7.8%, but 7.8% more than, how much percentage of is it going to be? Hmm? Seven 7.8? I thought it was 7.6. Okay. Mm. I hope I use the right numbers under my key. Okay. So I feel like this is combining a few different things that we talked about today, right? If we increase it by what, 7.8%? The first thing you think about is what, it's 107.8%. The other thing we talked about is we've got to convert that to decimal. We're multiplying that by something to get to my other number, right? So this is one of those ones you might have to do a little bit of back solving on. But I believe the way that we're doing it, and it should tell you a little bit, right? If it increased to get to here, we should be getting a smaller number. So using like the context of what they're telling you might also help you clarify whether you're going in the right direction or not. Sometimes, you know, does it make sense with what does your answer actually make sense to what they're asking? And sometimes students don't always check that, and it's creates some situations sometimes, a little bit of humorous, but what are y'all getting? 77.92? Is that what we are getting? We are getting 76. Where are you getting this from? Where's 65 coming from?
I didn't know what to do, so I just multiplied the numbers.
Oh man, this is at it's going up what, 7.8%. So it's going to go to 107.8% or 1.078. And we want to know, we're going to multiply that by what, the 2000 price to get to my 2016 price, which is the 84%. And so we're doing this in order to solve for X. We're going to take what, 84 and divide by the 107.8%. So this 7.8%, what is that referencing? The 7.8%. Which price does that reference? Because there's always some kind of base number it's referencing, right? Percentages are really deceptive because they're talking about, what they're talking about is a ratio, right? And if you don't know the raw amount, it's really kind of deceptive to talk about it. But right here, they're talking about this 7.8% should be on the 2000 number of households. So it should be 77.92%, somewhere in there. Going back the other way, we can go back maybe the forward way, right? That might make more sense. So if I take 77.92 and I add what, 0.078% of 77.92, I should be able to go back the other way and get the 84%. Or if I do 1.078 of 77.92, same thing, right? Just more condensed. There's one of them here. Plus 0.078. So the reference is the 2000 price. And since we don't have our reference, right? Anytime they don't give you the reference number, you're going to have to do some bit of back solving of some sort. Okay. I think we're on to the second to last problem or something. We're getting close. With 2.4 million digital subscribers, Game Informer magazine ranked first has 1150% more digital subscribers than National Geographic, which is ranked third. How many digital subscribers does National Geographic have? there's something that is like really kind of tricky. I'm going to fix this a little bit. So if it is 1150% more than, what is the percentage of? So if we're increasing it by 1150%, and we start out with one of them, what is the of percent of price? How do I get to the percent of?
Would it be by multiplying?
So how much is one, like in percents? If I take one of them, that's the same as saying I'm taking how much? Oh man, dudes, come on. I'm trying to get out of here for the weekend. What are y'all doing? Well, how much is one in percents? Like if I'm taking one of an object, how much is it of that object?
100%.
That's 100%. You're taking 100% and you're going to do 1150% more. What percentage is that going to give you? And it's a little weird because they're going over 100% maybe, but we're taking 100% and we're adding 1150. That's going to give me what?
1,250.
1250% of. There we go. So if we do 1250% of whatever the heck this thing is, it should be giving me this number. So what I'm hearing is I'm taking, that is what happens if I convert that percentage to a decimal. I'm going to take it of a number and I'm going to end up at the other number. Now also don't forget that this says millions. So know that you're working in millions, but I think that's it right there. If I'm being honest, like that vocabulary tripped me up the first time I worked with this problem. The more than versus the of, I was looking through it and skipped it. So like, it is like one of those things, if you're not paying attention, it's really easy to miss. I converted that, right? Yeah, 2 decimal places. Okay. So 2 decimal places. Or you can just give me it as a whole number because it is in millions. If you give me the other like whole number equivalent, that's fine too. Where we at? Almost there. One more. Oh man. All right, so I talked a little bit about it, but we're taking 2.4, we're dividing by what, 12.5. And that should be giving me something like what, 0.19, I think is what it gives me. But that 0.19, the important thing to account for is it is in millions. So you can give me 0.19 million. You can move this, it's like 0.192, I think, if you do all the decimals. So if you do that, it would be 192,000, I believe. If we move it 6, yeah. That's right. I think you might not got it because of like comma in there or something, right? But that's it. 192. It should have 3 zeros if we move it. Yeah, it should have 3 zeros if we move it to the millions. We got to move it 6 decimal places. And so I think the next one might just be is it another problem or is it actually working? No, it's another problem. Okay. Employment rate. One last one. Employment rate has risen more than a percentage point to 8.5 in February from 7.1 last November. What is the relative change in unemployment rate as a percentage? Oh man, this is like popping this thing back again. Okay. We want to do relative change. One last relative change problem between these two percentages. New minus old over old. Remember that thing. If you remember that thing, I think you might be pretty safe through most of this stuff. Are we trying to do this? One last one. All right, we did enough of these relative differences. It should be 19%, 19.71. 72, round it up. You're telling me. 19.7, just rounding. All right. That's it. Yeah, I got questions. I'm here. Congratulations. Dun, dun, dun. Go do your work. Have a good weekend.